Hello, everybody, and here we go with lesson 6. Good news is with lesson 6, you've actually done this before. It's factoring. We did that. We did a whole unit, half a unit at least, on that back in unit 7. All right, so talk about that here in a little bit. But just to make sure you're with me, what are the 3 ways so far to solve a quadratic? Graphing, right? That was lesson 3. Square roots. That was lesson 4. And complete the square. That was the last lesson, lesson 5. All right. And I kind of already referenced this, but in unit 7, we spent a good amount of time factoring, right? Remember what factoring was? It was taking a quadratic, which is what this whole unit is, and turning it into the product of its 2 binomials. Could this help with solving? Yep, it can. Before I talk about how it helps, you have to know a property that without this property, factoring really wouldn't do anything for us. But we have a property that we're going to talk about here. It's called the zero product property. What it says is if 2 numbers multiply to equal 0, then at least one of those numbers has to equal 0. All right, so if A times B, just 2 numbers, multiplied together equals 0, then either A equals 0 or B equals 0. So how does that apply to factoring? Well, x squared plus 5x plus 6. Let's look at that one. The equals 0, I just stuck it off to the end here, so we're not going to really think about that. That just tells us that we're solving this quadratic. So that is important, but for right now, I'm just focusing on the factoring. So 2 numbers that multiply to 6 and add to 5. I'm not going to spend a ton of time on that. That's just 3 and 2, right? Okay, so that factors into x plus 3, x plus 2. Now, what operation is happening between those 2 binomials here and here? Those 2 binomials are being multiplied, right? And the product equals 0, right? We've already talked about that. So that means we can apply the zero product property. So what's A in this case? A is actually that whole binomial, x plus 3. X plus 3 is just a number. It's a weird way to write a number, but it is just a number. And B would be x plus 2. So looking up here at the property, what we do is then we set those 2 values or those 2 binomials equal to 0. So if x plus 3 equals 0 or x plus 2 equals 0. When you solve both of those equations, and it's really easy, x plus 3 equals 0, I just subtract 3. You get x equals negative 3. And on the other one, you just subtract 2 and you get x equals negative 2. When you solve those, you've found the solutions, not only to those 2 equations, but to the quadratic itself. These, on this, if I would graph that right there, it would cross the x-axis at negative 3 and negative 2. Okay, so let's do a couple basic ones here. Clear that and scroll down a little bit. So solve each quadratic by factoring. So basically, we're just going to factor 2 numbers that multiply to 16 and add to negative 10. And I'm going to add the equals 0 at the end. Make sure that that's a little bit of a change, but it is important. All right. So that's negative 8 and negative 2. Okay. And then here's where a lot of people will stop. They'll just say, oh, I'm done. Cool. Because that's what we did in unit 7. We were done at that point. However, you got to take those 2 now, and x minus 8 equals 0, and x minus 8, 2 equals 0. Add 8 real quick. Add 8. And I get x equals 8. Add 2. Now, you're going to notice a little shortcut here, but I'm not going to talk about that yet. My solutions are 8 and 2. Okay, do the next one. X squared plus 9x minus 36. So 2 numbers that multiply would be 12 and negative 3. So then I take those 2 and set them equal to 0. Subtract 12, I get x equals negative 12. Add 3, I get x equals 3. So my solutions are negative 12 and 3. Now there is something I want you to notice. Look back at the factors. So in this case, the factors were negative 8 and negative 2. In the second one, the factors were positive 12 and negative 3. Then look at the solutions. Positive 8, positive 2, negative 12, positive 3. Okay. What I want you to notice is the solutions are not the same as the factors. The signs change, right? That should make sense because if you look at the solving portion, all you're doing is taking a negative 8 and adding it, which changes the sign. So I've kind of just told you the shortcut, but if you didn't get it, ask me in class. All right. So, but big thing is the solutions are not the same as the factors. A lot of people write the factors as the solutions. Don't do that. Now on the backside here, we've got some of the trickier ones. Okay. So I'll show you some of the things that can be a little bit tricky with factoring. Jump right in here. Number one, looks like it looks a little bit weird because the C value is actually 0. That does happen every once in a while. And when that happens, I actually have a GCF. Now you might be thinking, I can't take anything on a 0. You're right, but that equals 0 isn't really what I'm looking at. I'm only looking at that part right there. I'm going to factor that part. So I can take an X out of both of those. So I'm going to divide both by X. So remember, I'm going to create a little more space here. Remember, when you divide by the GCF, that you want to write it on the outside. X squared divided by X is X. Negative 7 to X divided by X is negative 7. Equals 0. Now you might be thinking, well, there's only one solution. Well, no, there's actually 2. This part right here is a factor. So X by itself equals 0. And then X minus 7 equals 0. Add 7. The first equation is already solved. It's just 0. And you get X equals 7. So my two solutions here are 0 and 7. Okay. Make sure you pay attention. And if you didn't get that, make sure you rewind and watch that one again. Okay. Number 2 looks like the same thing, right? No C value. Wrong. This is not equal to 0 right now. It's equal to 12. I can't have that. What I need to do is I need to get this equal to 0. I need to move 12 over. How do I move 12 over? Well, I subtract it from both sides. This seems weird, moving 12 over with X, but we have to do that to get ready to go for solving this quadratic. Why? If it's not equal to 0, the 0 product property does not apply, right? So you've got to do that. All right, so X squared plus X minus 12. Now it's a normal problem. Two numbers that multiply to negative 12 and add to 1. That would be 4 and negative 3. If you've caught the shortcut, you might be able to figure this out. X equals negative 4 and X equals 3. What I did was I just flipped the sign of the factors. If you didn't get that, here's what I did mathematically. X plus 4 equals 0, X minus 3 equals 0, and solve both of those. Okay. Number 3, A is not 1 here. It could be a special case, but old school factoring. Okay. I'm going to go X squared. By the way, there's no GCF here. It's a good thing to look for. Plus 20X plus 100 equals 0. So that's going to be X plus 10, X plus 10. But I've got to remember to divide both of those by the number I multiplied by. So 4, reduce, those reduce down to 5 over 2. Okay, and then I slide the 2 to the front. I get 2X plus 5, 2X plus 5, oops, forgot the 2, equals 0. Now you don't have to set both of those equal to 0 because they're the same. You're going to get the same answer. but you probably should write it out. This is not as easy as just taking the opposite sign because I got a 2 on there. So I got to subtract the 5. I get 2x equals -5. And then divide by 2, I get x equals -5 over 2. Okay, so you will get some fractional answers at times. Probably are aware of that, but I'm going to clear that and do number 4. Important to check for a GCF because this one has one, and that GCF is 3. So I'm going to go ahead and take a 3 out. So 3 comes out, and I've got x squared plus 7x plus 12 left over. Now I got to factor that inside part, which is not hard because a is now 1. So that's going to be x plus 3, x plus 4 with a 3 on the outside. Now I'm going to do something here that a lot of you are going to be like, what? That 3 is actually not a factor in this. There's no x attached to it, right? If I set each piece equal to 0, 3 equals 0 doesn't make any sense, right? So what I'm going to do is I'm going to, since it's all being multiplied, I'm going to divide by 3. What that does is it cancels the 3. Divide by 3 on this side. That doesn't do anything to my problem. X plus 3 times x plus 4 still equals 0. And now I can get my solutions of -3 and -4. So in number 4, the GCF, since it was just a number, just left. Back on number 1, the GCF was a variable. So that was part of the answer. I can't just divide by the variable, okay? It's a little bit tricky, but something you do have to pay attention to. All right, 2 more here, and then a word problem. This one's one of those special cases. The middle term's gone. So these two have to be the exact same except for the sign. So 3x and 3x, 4 and 4. And now I just set those equal to 0. All right, so subtract 4, I get 3x equals -4. Divide by 3, I get x equals -4/3. Probably guess what's going to happen over here. You're going to add 4. You're going to get +4/3 on this one. So +4/3. Last one before the word problem. No GCF on this one. So I'm going to go ahead and multiply by 3. X squared minus 2x minus 63 equals 0. I get x minus 9, x plus 7. Then I'm going to divide by 3. This one reduces to x minus 3. This one is not reducible, so 3x plus 7. Now you've got to set both of those equal to 0. That one's easy. That's just x equals 3. Second one's not as easy. 3x plus 7 equals 0. Subtract 7. 3x equals -7. And then divide by 3. -7 divided by 3 are my two solutions. Okay, a couple things real quick. What other method could I have used to solve number 5? So looking back at this one, hopefully you see that you can use square roots there. You could have done square roots because b equals 0 on that one. Okay. Some of you may not remember factoring like number 6. The next lesson is going to show you a way you can solve this without having to factor. So if you don't like that factoring, there's another way, which is good. Okay. We're going to talk about that more later though. For now, let's finish this video and look at the last word problem. All right. So the length of my desk is 3 feet more than the width. If the area of my desk is 28 feet squared, what are the dimensions of my desk? And I want you doing this algebraically. You can probably figure it out by guess and check. But that's not the point of this. The length of my desk is 3 feet more than the width. So there's the width, there's the length. So the length is 3 more than the width. So width plus 3. So I'm going to replace the L with W plus 3. The area of my desk is 28 square feet. Okay. So what I'm gonna do is I'm gonna multiply the length times the width. So W times W plus 3, that's the area, right? Length times width is the area, but I know the area equals 28. So I'm gonna distribute. So W squared plus 3W equals 28. We have something very similar to number 2 on this paper right here on the back side. I need to get 28 on this side. So I'm gonna kind of take my work down here. W squared plus 3W minus 28 equals 0. So I subtract 28 back over to the left side. Now I can factor W plus 7, W minus 4. Set those equal to 0. W plus 7 equals 0. I get W equals -7. W minus 4 equals 0. W equals 4. How can I have 2 widths though? Hopefully you notice that the width being negative doesn't make any sense. I can't have a negative length. That one doesn't make sense. So my width is 4. So my W is 4 feet. My length then, I can go back up to my original comparison equation and take 4, which is my width, add 3 to it, and I get my length is 7 feet. Okay. And that's how a word problem would apply with factoring. And that's it for this lesson. We got one more method and then almost done with the unit.